Okay, finding the empirical formula from experimental data, we can do an elemental analysis on a molecule and find the ratio of the weights of the various elements. So say we do an experiment and we find that for the element carbon, our sample consists of 9.6 grams. For hydrogen, we find it consists of 2.4 grams. And say oxygen, the sample consists of 6.4 grams. So let's find the empirical formula from this data. Now the empirical formula is a number ratio. In fact, it's the lowest whole number ratio of the elements in the molecule. So what we've been given experimentally is a mass ratio. So we're going to have to convert from a mass to a number ratio. And we do that by counting molecules. So we're going to go from grams to moles. We count molecules in units of moles. Just like you count eggs in dozens, we count molecules in moles. Find out how many moles of carbon, hydrogen, and oxygen are in our sample. So we have 9.6 grams of carbon, and there's 1 mole per 12 grams of carbon. We find that from the periodic table. That gives us 0.80 moles of carbon in our sample. Do the same thing for hydrogen. 2.4 grams of hydrogen times 1 mole per 1.0 gram. We get that from the periodic table. That's equal to 2.4 grams of hydrogen. Then we calculate oxygen. So we have 6.4 grams of oxygen. And from the periodic table, 1 mole weighs 16 grams. And so that's 0.4 moles of oxygen. So now we have a number ratio. You'll notice they're not whole numbers. So we can convert to whole numbers by doing the following. Let's divide each number of moles by the smallest number in our sample. So what we have is C 0.8, H 2.4, and oxygen 0.4. So we'll divide everything by the smallest number, which is 0.4. And as long as we divide each number by the same, we're not changing the relative amounts. So we have carbon 2, H6O1. So that is our empirical formula. That's the simplest whole number ratio for our molecule. Okay, if we knew the molecular weight of our molecule, we could determine the molecular formula. Now say we find the molecular weight is 46 grams per mole for our molecule. Let's find the empirical weight. So the empirical weight is equal to 2 times 12 plus 6 times 1 plus 1 times 16. And this is all as units of grams per mole from the periodic table. So this is equal to 46 grams per mole. So if the empirical weight equals the molecular weight, then that means the empirical formula equals the molecular formula. So that means our molecular formula must be the same, C2H6O. Now say we do another experiment in which we have nitrogen and oxygen, and we find an empirical formula of NO2. That's our empirical formula. We found this from experimental data. We measure the molecular weight and find it is equal to 92 grams per mole. So let's compare that to our empirical formula weight. The empirical formula weight is equal to 14 plus 2 times 16, all in units of grams per mole. So that's equal to 46 grams per mole. So now, the molecular weight does not equal the formula weight, but if we take the formula weight and multiply by 2, 46 grams per mole, times 2, that would be equal to 92 grams per mole. So, our molecular weight must be twice the empirical weight, and the molecular formula must be twice the empirical formula. So our molecular formula would be N2O4. We just double the amount of each atom ratio. So that's our molecular formula.